So right now I am wiring the new Spark controllers to our 4-sim drivetrain. We're using center drive, and so the 4 motor controllers are right here, and then those we wired back to the PD board and the oRyon, which is not right here right now. Our robot will be using the battery and the most electrical components to be back heavy.
Okay, what's up everyone? My name is Andrew DeGaulle and I'm here to give you an update on Team Orion's Day 2 of Robot in 3 days. So because school starts tomorrow for some folks, we had to move from the classroom we were originally working at Straight Jesuit down here to Audi International High School's robotics lab. So we got a lot of work done today. As you can see, the drivetrain is completely finished, and after some testing over some of the game obstacles that one of our team members' parents made, we're liking it a lot so far. We have most of our electronics wired up, and we actually used Red Robotics' new Spark controllers, and we're liking them a lot as well. As I said yesterday, we decided to go with a short design, and we completely went forward with that. Over here on the robot, you can see the start of our arm structure. On the front of this arm is our intake, and Cooper's going to go ahead and explain that a little.
Alright guys, I'm going to talk about the intake and the CAD progress we have. We've kind of mocked up one of the options we have with the material to use on the intake to get the ball into our arm. It's surgical tubing right now. I don't necessarily know if it will stay that way, because it's not attached very well. Zip ties are not the best way to attach your friction material. But this will ideally pivot a little bit to either vary the compression on the ball that we have, and this is going to go mounted on the front of the arm that we currently have on the robot. Alright, so here's what we have done on our CAD. We have our arm fully in there, our intake fully in there. We're going to use an intake that's almost the full length of our robot, so you don't have to be very accurate to go and pick up a ball. You just have to be in the general area and get the front of your robot somewhat near the ball, and it will suck it right in. The arm is going to pivot up and down to be able to get over obstacles, and there's going to be a ramp on the bottom side of it so we can have a higher approach angle, and so we won't bottom out on our frame. I think other than that, it's pretty simple, and we also have it less than the 15 or 16 inches, I think it is, but we went with the 15-inch frame so we can easily get under that canvas in position 1. Alright guys, so if we progress enough tonight, hopefully we can move into our high goal scoring mechanism. What it is, it's kind of a linear punch that's driven by a piston to pull it back. It's kind of going to act like a crossbow per se. And it's going to have a latch in the back after a big piston pushes it back and pulls back the surgical tubing on it. And then once we want to fire it, we'll release the latch, and it should go forward and propel the ball into the high goal. We're using mostly the stock we have, so lots of 2x1 and maybe a little bit of the Ri3D Robotics rail, I think it's called. And then it should fit pretty seamlessly into the arm we already have designed. And that's if we get as far as we'd like to tonight, then we'll move into working on that.
Thanks for watching guys, and I hope you guys tune in to the last day of Robot in 3 days tomorrow. And tomorrow we're actually going to be doing a lot of testing, so I'm sure you guys want to look at that. And make sure to watch our reveal video on Tuesday.